Oops. I'll leave that. Differentiable. All right, so moving on to 57, 58. Hope those go a little smoother. No irony intended. Irony being, of course, that it was the smoothness that was my undoing in the last graph. All right, so number 57. Piecewise again. Let's see here. That means that f of x doesn't mean it. Defined 2x minus 3 and x minus 3. And this one is from negative 1 less than or equal to x less than 0. And x minus 3 from 0 up to 4. So do a quick sketch. 2x minus 3, so that means we're down here at minus 3. Negative 1 to 0. So that means it goes down from there to there. And see, so that's a closed circle at negative 1, and an open circle there. And then x minus 3 from 0 to 4. So we're filling in that circle. And then we go all the way up to 1 over here. So this is at 1, this is at negative 3, this is at negative 5. And this big closed circle up there. So we're talking about differentiability. Differentiable. Got a corner there. Corner can easily be seen because your slope here is 1 and your slope here is 2. So that's bent. So for A, we're differentiable everywhere, not at 0, but we're not defined on the whole real line here. So we're differentiable. Let's see, from negative 1 up to 0, and from 0 to 4. The book has these as open brackets. I'm looking at the answers correctly, but I don't think that's correct. I think that should be closed bracket. Because if you're differentiable on the end of an interval, that's perfectly acceptable. Or if you're continuous up to an end of an interval, then you're differentiable at that point. So that's good for B. Continuous but not differentiable, well, that would be at x equals 0, but rather, just at x equals 0. And then C, neither continuous nor differentiable. Well, it's nowhere. We're perfectly continuous. So nowhere, provided we're on its domain up here. All right. That one was nice and easy compared to the last one. That's good. I'll make mistakes. Everybody makes mistakes. Let's see here. 58. G of x is x minus 1 over x, where from negative 2 up to 0, and it is x plus 1 over x, and it's from 0 to 2. There's our function. Clear we're not continuous at 0, that's for sure. So let's look at each one of these. See, we do this one in blue from negative 2 to 0. So we're talking about on this part of our x, negative 2, negative 1, 0. And it's x minus 1 over x. So that's just 1 minus 1 over x. So it's going to asymptote here at 1. And it's negative 1 over x instead of in the first and third quadrants. So it would be like this and like this. We're only defining here, so that's from about here. That continues asymptotically there. And then this one, we can do over here in pink. well, this would be 1 plus 1 over x. And so that's again asymptote at 1, and then we're where we expect to be here, and this stops at 2. This range, 1, 2, that sort of stops hard there, and stops hard here. So that's our graph. So we can see that we're clearly non-continuous at A, at x equals 0. So we're differentiable everywhere, no problem with that. So we're talking about from -2 up to 0, and then from 0 to +2, close bracket. B, continuous but not differentiable. No, we're differentiable everywhere we're continuous. There's nowhere. And C, neither continuous nor differentiable. That would be at x equals 0. And not sure with a piecewise function why they would have bothered to put that equal to, because you're defining something that's undefined. So that's, I guess it's in there so that we actually have a third category for once. But of course, rationally, no pun intended, rational functions, we would have eliminated that. That was 58. 59, curve sketching. So, have a graph. We want to sketch the graph of its first derivative. So we're just taking the slope at each point. I'm graphing what the slope is. Let's see here. So our graph looks like let's see, -3, -2, -1, 1, 2, and 3, and up to 1, and down to -1. And so we run -1, 1 up to 1, 1. And that's open circle here. We're defined x equals 1 there, and then come back down to closed circle here. 3, -1. I'm going to kind of have looks like a little logistic function or some such. It kind of looks like that. All right. So we need to find the graph of all the derivatives. So this is good old y equals x. So the derivative from, or the slope from -1 to 1 is just 1. So from, let's see, so -3, -2, -1, 1, 2, 3. Yeah, so there's 1, 2, -1, -2. So from -1 to 1, slope is just 1. And we don't have a slope at the endpoints. So we're going to put open circle here. And then our slope is -1 thereafter. -1 from 1 to 3. And previous to this, it looks like we're kind of approaching 0 again. Up here at the top, we kind of get pretty big, but then we go back down to 0 again. So we're almost 0 here. We're almost 0 around, I think we'll be back to 0-ish around 3. Maybe a little bit less. And we approach a 45-degree angle, so almost as much as this. So maybe how about something like that. I think that looks pretty good. So looking at our slope, I'm trying to pencil or something like this, a paintbrush. So there, our slope is more or less 0. Let's see if I can bend down there. The slope is 0. Slope increases at -2, decreases down to 0 again at -1. And the slope is 1 all the way over here. And the slope is -1 all the way over here. Hope that was visible in the camera. We can't do number 60. Yeah. Oh, we're gonna knock 60 out. Use the same color scheme. We have our initial graph. Got a couple asymptotes here. Asymptote to the left. Asymptote on the right. And a horizontal asymptote here. And our curve looks like that. And then kind of down like that. But this is almost flat there. Let's redraw that. As such. And one looks like this. Alright. That looks about right, according to the book. I'm trying not to look at that part. There we go. Alright, so they are same axes. So I have a gap in our graph here and here. This is huge slope. This is 0. So let's note that we have this point 0 here. There's an enormous slope over here at the right. So that's huge. Very, very high. Have our same enormous slope here, but then we level out to 0 again by the time we're over here. And this is about 0 over here. And very, very positive, very, very positive around here. So we're looking at this and this, and very, very positive, very, very positive. So I'm kind of looking at that. On either side of each asymptote, a very, very positive slope. Very positive, very, very positive. Almost 0 there. Yeah, so let's say that actually does hit 0. So let's go ahead and it is asymptotic over here. So that means that we don't actually hit 0. We're always slightly positive, so it's still kind of asymptotic like there. This here, this gets very, very positive, smaller, 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 but never actually goes negative. So it just comes down to where it's 0 here, and goes back up to very, very positive. And very, very positive, and then we kind of edge out to 0 here. We don't actually hit 0. It's kind of like the Golden Gate Bridge. But that's good. No math involved, just some spatial recognition skills, I guess. Spatial reasoning skills.